was actually illegal
Yeah.
here too, so.
And then
There's more than just going 1, 2, 3, 4, 5.
slightly. If only. You always depend on me.
No. So exact sound you made. Just put 'em in notes.
Except all day.
Okay.
You won't accept just saying, yeah, that would work like that because it,
Just because? Just because you felt like it?
No, people look at it and say, yeah, that would be fucking equals.
Because I felt like it.
Right.
No, I can't accept that.
No.
Actually, I could accept it, but I won't. We'll say that. There's a difference. I can't in one.
Oh, neat. Found that.
It's still just not waking up when.
No, that's not even, that's just me not saying I was physics.
That good.
You know, invariably, every semester, somebody asks me that question.
I only asked because I was just talking to Dr. Cooper.
Wait, what was the question?
And,
How good am I at physics?
Uh,
Invariably. You know, I think the question is how bad is somebody at physics? Because no matter what, you're going to be bad at it. You're going to fail no matter what. It's just to what degree do you fail?
sure.
How much do you understand?
Oh, I'm only slightly bad at it. That's actually pretty good.
All I know is I've not met anybody teaching that understands physics as well. Now, I've met people that I work with that probably understand physics better than him, but I can't even understand them in, regular, everyday conversation. They are disjointed.
Yeah, physics animal is a different breed. We'll say that.
Yeah, you guys ever taken a class on?
Cooper?
Yeah.
I hear.
I didn't. I just.
I have not to take physics here.
Just
so I'm
dropped
not going to.
yesterday.
Yeah, that's what I was.
Winner.
He's hard.
Yeah.
John, that's my dream.
He'll teach you.
What?
That's my dream game.
You also have to do the
I just
work
dropped
and
that
understand it to do well in the class.
I dropped
Are you
computer
doing
science.
first physics class, you do a 3?
That's all I
And
said.
then I came
What was your-
to majors, so I didn't need to take the other one.
Oh, okay. Yeah, so did I.
Drop
So I
my
didn't
dead
either.
classes.
I needed the first one. I got.
Nobody's dropped the screen.
Nobody's
I
what?
like
Nobody
this
said
stuff.
nobody's dropped the screen. I need to be harder on that.
I don't think so.
Math's supposed to be fun.
It is supposed to be fun.
It's supposed, everything's supposed to be fun. Learning's supposed to be
And
fun.
for the most part.
Yeah.
Living is not supposed to be like existential crisis.
The government's supposed to protect us. Now we can all really laugh.
The real
And you work for Greg, he's coming
Ah.
late. Not this Greg, okay.
Gotcha. Well, I figured that.
I'm
Great,
here.
since
You can get through this, I appreciate it.
It's weird. It's not here. I can't hit him with anything. It's like I'm missing a part where It's good.
Maybe he's just running late.
Don't wish that people.
Scare him off.
I wish. Poor Don, in true story, I wouldn't talk badly behind Donnie's back. Yeah.
Where is Donnie?
Donnie took me for Calc 2 8 years ago. There he is. Donnie, how long ago? No, seriously, we were just talking about you. How long ago did you take me for Calc 2? Was it 8 years? Like, seriously?
Nah, it was,
It feels like
14.
it feels like it's been a long, long time.
Cause
Seriously.
it was, my wife went to nursing program 2 years ago, maybe, so 3 years ago.
But that was for scientific and computation, wasn't it?
Wait, yeah, that's right.
Because you took me for Calc 2 way before that. And then you appeared again out of nowhere. And then once again you appear out of nowhere. I thought I was done with you. It's like I finally discovered Valtrex and my herpes was on or something like that. Not comparing you to herpes.
Just the experience of herpes you got compared to.
Maybe 4 or 5 years, yeah.
Well, that was for scientific and computation, because we haven't offered that class in literally 4 or 5 years. So, go find one of your old tests. You know, the ones with the
I
big.
still have my binders.
Okay, yeah, go ahead. I'm actually interested to see, but I think it's like been 7 or 8 years. Yeah.
At least I'm still trying.
That is true. I will say that about you. You're still trying to fail. So. He actually passed all my classes. I don't know how, but he did. You are. Okay, guys. So I think we have to go through and do one more of my the problems involving the set stuff. And this one, unfortunately, is going to be much more difficult than the other two we looked at on Monday. And then we're going to take a look at counting methods. And when we say counting methods, it has to do with more like probability and being able to do those sorts of things. Okay? And then just a reminder, guys, that assignment number 8, so assignment number 8, that's going to be due on, what did we say, Monday, correct? And even more specifically, Monday, October 31st. So not any month, and we'll say 2016, so that way you don't get to select which October 31st you
Is
get to
it
select.
AD or BC?
We will go with AD since it might be physically impossible for you to submit it that long ago. Okay.
Hey,
All right. Any questions, guys, I can answer? Okay, so let's go ahead and try this animal right here. So we want to prove this, and this is actually a fairly common proof that a lot of times you see in, with set laws. So difference of sets A and B minus difference of sets B and C is always equal to A minus B. Okay, now this is true, okay, so I'm not going to give you guys ones that aren't true. So let's go back to Monday. And remember I gave you guys that sheet with all the different laws on it? That might be appropriate to help us out. So if I was to ask you guys which law to begin with, guys, which is the most obvious law to begin with?
Set difference.
Set difference, right guys? So you got to start with set difference. So let's do that first. Good. So this is going to be A intersect B complement, intersect B intersect C complement, complement. Okay, so everybody see what I did there, guys? There was the minus that was in the middle of the first parentheses. Then this minus became an intersection complement as a result of the second set difference. And then inside we have a set difference there.
But that should, oh yeah, I got it.
Okay? All right. And that's going to be equal to A minus B. And that's just our set difference. Okay. By the way, this is on the last page of the packet we looked at on Monday. Okay, so just reminding you guys, this isn't the new packet. Okay? All right. Now, this looks very tempting to use the associative law on it, doesn't it, guys? Because there's a whole bunch of the same symbol. Unfortunately, we can't use set difference because of this complement right here. Or, I'm sorry, we can't use associative property. So does anybody think they might have a
De Morgan?
suggestion? Yeah, I think what we would have to utilize at this point is the De Morgan's law. Okay, so let's use De Morgan's law. So we're going to say the first set stays the same, A intersect B complement. Intersect. Can somebody tell me what's going to go inside that second parentheses once we utilize the De Morgan's law?
Is, sorry, B complement, then the was the union,
Union.
C complement.
C.
Complement, yeah.
Complement, complement. Nice. Okay, so C complement, complement. Because remember, you have to apply the complement to both of the sets inside and then flip over the intersection. Okay, that's going to be equal to A minus B. And that's our De Morgan's. Okay, nice. I think everybody knows what the next step's going to be, and then they want to quit on this one. Okay, so what's the next step that looks so obvious it hurts? Double complement law, right? We have complement, complement. In fact, if you wanted to, you could skip that one. Okay, you could just go right to complement, and I'm okay with that. Okay. So this is going to be A intersect B complement, intersect B complement union C equals A minus B. Okay, so that's our double complement.
Now, do you write A, can you do the quote, A minus B on the right all the time?
What do you mean? Oh yeah, you can just use the double quotes on that. That's
Okay.
fine. I figure it's just literally 2 lines
Okay.
or 2 characters, so I'm not going to.
No, but I'm lazy, so I.
That's okay, you can do that, you're efficient. All right, now this is where a lot of students look at this and they're like, you know what, I just quit on this one, okay? We'd like to be able to use like maybe some sort of absorption law, I think, on this one to make it really easy, okay? So one of the things that students might try to do, and I don't want you guys trying to do this, is they want to take this and distribute to both of those, okay? And unfortunately, I don't necessarily know if that's going to be the best way to go about it. Not saying it's not wrong, okay? But I don't know. We'd like to be able to use absorption if we could, but unfortunately, this isn't exactly the same as what's in here. Okay, so I think, unfortunately, the only way to try to do this next step is to actually use the distributive law and distribute quantity to intersect B complement to both B complement or C or union C. Okay, we don't want to do that if we don't have to, but I think in this instance we kind of have to, unless somebody else sees another law that we can use. But
Could you possibly use the associative to just move the brackets over to contain like that whole second expression?
we could, John, if this was an intersection. Unfortunately, because there's different, because these are both intersections and this is a union, we can't move those around, okay? It only works if they're the exact same. I see what you mean, what you're trying to do. The only thing you could possibly, and you couldn't even group these two again, unfortunately. So, yeah, I think we're stuck with this one. So, and I think there's one on your guys' homework, the last one, where you're going to have to use this technique. So I want to make sure that you guys are okay distributing this to both. Okay, so if I were to distribute this, okay, the way this would look is I'm going to have one bracket, okay, because I'm going to put A intersect B complement, and then intersect B complement. Okay. And then union bracket A intersect B complement, and then intersect C. All right, so that's supposed to be equal to A minus B, which it will be. So that's our distributive property. So I want you guys to take a look at that and make sure you understand how I distributed those, okay? And like I said, there's going to be one on the homework where you guys are going to have to do this, okay, unless you don't want to get it right, okay? But hopefully this isn't too difficult to understand. But does that make sense? Any questions about the distribution there? Okay. Now, I think at this point we might be able to use that associative law, can't we, guys? Because if you notice inside the brackets, we have all intersections. That's okay to do. I'm not going to mess with this guy over here, and I'll show you guys why in a moment. Okay, so all I'm going to do is I'm just going to move the parentheses over for this guy right here. Okay, so this is going to work out to be bracket A intersect quantity B complement intersect B complement. That's just an associative law. Okay, that's completely okay with everybody. I know you guys know associative law. The second guy, I'm going to leave him exactly as is, okay, because we're going to hope something good happens. Union A intersect B complement intersect C. If that C wasn't there, our lives would be great, okay, but we have to somehow get rid of that C. Okay, we don't have too many laws that allow us just to eliminate one of the variables or one of the sets in this case. Okay? That's just an associative law. And I bet you most of you guys see what the next set is if you're focusing on that first bracket set. So, does anybody think they might know what's going to happen next with this animal? Yeah, guys, take a look. a look at B complement and B complement. Guys, if you have A and A, it's equal to A. So, and Greg, that was what idempotent, so? Okay, so B complement and B complement is just B complement. Okay, so let me go over the other board. By the way, we're literally about 2 steps from being done with this. Okay, so this is going to work out to be bracket. Well, actually, we don't even need the bracket anymore. This is going to be A intersect B complement. Okay. We could put the bracket there if we wanted to, but in reality, we've only got A intersect B complement going on now. The other one is going to stay the same. Okay, so this is going to be union bracket A intersect B complement intersect C equals A minus B. So that's our idempotent law. So, suggestion at this point, maybe. Well, absorption, okay. Greg, what do you see up there? Do you see 2 sets that are completely identical?
Yes.
So, if you were to look at this set as what, like maybe A,
Mhm.
and this set as A, and this C is the B, well guys, that's an absorption law, okay? Let's take a look off to the side. Absorption says that A union, it doesn't say anything.
Check that out.
The whole building.
Alright, coming back.
Oh, nice, it's getting worse. Oh, there we go.
Movie time.
Put a sign for somebody hang on paper.
What's that?
Sign, put a sign for somebody hang on paper.
Anyway, it's too easy, I'm not gonna do it. Alright, guys, don't we see on our sheets there, if we have A union A intersect B, that's equal to A, where A is a unique set and B is a unique set. Think of this as set A, and think of C as set B.